What's up guys? Um, Welcome to our tutorial today, and I am in the lathe machine and I will show you how to program a simple turning on lathe machine using our cycle on manual guide eye. It is very simple and easy to follow, so I made a simple drawing for our guide and I'm going to show you how I will do it. Let's get started.
Ain't nobody stopping me.
Guys, this is the drawing that I made for our reference. So we have 20mm diameter and another diameter is 50, and we have 2.5 by 45 degree chamfer and another 1 mil by 45 degree angle on the big diameter, and we have 2 mil radius at the corner, and the distance from the base to the step OD is 25 mil, and we have another 25 mil on the big diameter. Okay guys, so my machine is running, and I will take this opportunity to show you how to program a lathe machine. The first thing we are going to do is go to background edit. Since my program is on data server, so I will use the CNC memory. Select, go to user and path number 1, and I'm going to create a program, say simple turning. Create, then open. Then guys, since I have the registered fix form, so that's the one we are going to use. Fix form. And we have the program header. So insert. If you have the drawing number, title, customer, OP description, so what kind of operation are you going to do, like turning. So you have also jaw type, what kind of type, chuck pressure, tail stock if you are using tail stock, and tool this. This one guys is just our trial, so we don't need to fill that one in. And go to again to fix form, and we are going to select our program start, insert, and then we have guys G40, G99, G0, G80, G18, and we have G30 U0 and G30 W0. that will go to home position. G19100 is our stock or cylinder blank. So to open that one is just press input. So our outside diameter is 50 mil. Let's say our stock is 55, so we make this one 55 mil. Input, and the length is that's 50 again. So we make this one, let's say 70. So 70 mil. And work origin set is 1. Input, then alter, and then guys we are going to fix form again. Then we will go to turn tool start, insert. Then now we have this tool start, So we are going to use tool number 1 for our wrapping, N1 for our sequence. And then guys, you have the process tool info. We are going to change the name, CNMG R.8. And then guys, our G50, say our maximum speed is 1000. And then guys, this G500 is, you are going to open this one just to alter the information. So input to open 1, offset number 1, direction of rotation 3, spindle RPM put 60. Then guys, our position on X is, since our bar diameter is 50, so we can position to, let's say, 52, and Z 20, and then work coordinates is 54, so we are going to use D96. And then coolant, if we want coolant, M7 or M8, so M8 input, and then alter. So we have this M24 is for our conveyor. Then the next process we are going to do guys is go to cycle, and we are going to paste first our material. So turning paste, input or select, and then guys, we have this cutting direction, X minus, cut of depth, so 1 mil, cut rate of cut depth 100%, X axis finish amount 0.3, Z 0.1, cutting direction feed rate is say 0.35, and cut rise feed rate, so I'm not going to put any feed on that one. And go to right cursor, go to the detail, first speed override 100%, cut rise method, high speed, escape amount, so we leave it 0.5, X axis clearance 0.5, it's okay, Z axis clearance 0.5. And then we have our approach motion. So if you want to, the first move is moving the Z first before X, so you can select this one. Or if you want X first before Z, you can do it, or to axis. But I'm going to select Z first before X. Then packet cutting, so I will put nothing, and then I have completed all the box, so I will go for insert. And then guys, the start point of my pacing, so since my material is 50, so I will start at 55 so that I am safe. 0, okay, and then I will select line. It's going down because I'm going to do pacing, so my end point is, you can put -1, input, and then last connection nothing, and the element type guys is part, and then okay, and then go to line again and going to the right. So I will put 1 mil because I'm going to paste just 1 mil on the job. Input, then nothing, and then that one is blank, and then okay. Then guys, press this key, then you have this black continue, so you can press that one, and you have selection if that one is figure number 1 or figure number 2. So since this one is showing that's what we want, figure number 1, so select it. The machine will ask you to select blank is connection, so yes, and then you are going to create, and then insert in current program, because we are not going to use a sub program. Okay, and then guys, we have now our program for pacing, wrapping pacing, and then we are going to put another NO block so that we have space, and go back again to cycle. And now guys, we are going to use our turning outer wrap. Select, and then cutting direction is Z minus, cut depth let's say 2.5, 2.5, cut rate of cut depth 100%, finish amount on X 0.3, 0.1 on Z, and our feed is 0.3, 0.3, cut rise, so we leave that one blank. Go to detail, first feed override 100%, cut rise method, escape, so we leave it 0.5, 0.5, approach motion the same, and then pocket cutting. This we are not going to cut the pocket, nothing, and then we use unavailable for end pace machine, insert. So now guys, we are going to do our turning. Since our first diameter is 20 and we have a chamfer of 2.5, so 20, we are just going to multiply this 2.5 by 2, so it's 5 mil because this one is a 45 degree chamfer. So 20 minus 5 is 15, so we minus again another 1 mil, so that we have extra 0.5 on radius. So we put this one to 14 mil, and our set is set 0, and then okay, and then we go to line. Next move is up, going to diameter 20, so we input 20. Last connection, nothing, and part, because that one is part. Okay, and then the next move is going to minus 25, line again, and then left, minus 25, nothing part. So okay, as you can see guys, I didn't put the chamfer first, so we will come back on this one and the radius and the another chamfer, and go to line again, going up, so the diameter of our big diameter is 50, nothing. Okay, and then guys, another 25, so 25 plus 25 is 50. So now we are going to line again, going to the left because that's Z, so minus 50. Okay, and then guys, we are going to go up for our escape, so line again, up, let's say we make that one 52, nothing part. And then guys, okay, after that one, the one I show you before, so go to the left cursor, select this block continue, and then you have figure number 1 or figure number 2. So now we're going to select again figure number 1, select block is continue, yes. So now guys, we have our shape, but there is some lacking detail, the chamfer and the radius. So again guys, you can see this on your monitor. You have line, arc, then another arc, and corner radius, then chamfer. Since we need chamfer, so what you need to do, guys, is highlight your line after your start point, and you are going to put 2.5 chamfer. Just put 2.5 and the machine automatically will create your chamfer. And same with this one, so that one is 2 mil, corner radius 2 mil, input part, and then on the top is you have 1 mil chamfer, 45 degrees. So chamfer 1 mil. Okay, so now, guys, you have your chamfer and the radius. So we have now our shape that we want. And since we are done, so we can create if you want to recalculate, so you can recalculate so that you can see if there is something wrong on your shape, on your drawing. So create, insert in current program. Okay, and now, guys, you have now your program, but we need to go to our tool end, go to fixform, and we are going to look for our tool end on our fixform. Insert tool end fixform. You have G30 U0 and G30W0. Then stop the spindle spade on main spindle, that is P11, and coolant. Then stop the conveyor. Then you have MO1. And then, guys, if you want to make your finishing on turning, you can just copy this one from N1, copy up to the bottom, copy, and then paste. You can make this one M30, and then you are going to change this one to N2 for the sequence, and change your name TNMG. Say we use 0.4 alter, and we are going to open that one, G500. So tool number 2, so we can increase this one to 200 for our finishing. Same, we are not going to change anything, alter. And then, guys, as you can see, if you highlight this line, says turning phase wrap, so you can delete this one, delete, and then right key and select the cycle, and then we can select the finishing phase finish, select, just input, then our feed point 15. So that's the only thing we are going to do, insert. And since we still have our figure, so just cancel. As you can see, guys, you have your turning phase finish, and on the bottom one is our turning outer wrap. So we can delete that one. We are going to cycle again, and then look for our outer finish. Select, same cutting direction, going minus. So our feed is, say, 0.2, clearance on X, 0.5 on Z, packet cutting, nothing, and then insert, then cancel. So now, guys, we have now our program for our simple turning. We are just going to run this one in simulation, and let's see if our program is going to work. And also, guys, another thing you need to remember, if you are using Panoc series on manual guide eye, it is very important, guys. You tell your tool what kind of tool you have, just like this one. So if you are using turning or for OD and ID, you must use general. As you can see, there's a symbol of turning, and you will set your tool to 1 because that one is spacing or turning, so number 1. So you can see on the drawing what kind of tool you are using. So it's up to you guys what kind of which one are you going to use, but this one is very important. And your cut angle, so cut angle should be 95 for your turning, but depends also for what kind of turning tool you have. And the nose angle of your insert, so the one I'm using is 80. And then guys, you have your radius. I'm using 1.2. And vertical tip is I'm using 3. That's for turning. So if you are drilling, you are going to use 9. If you are internal diameter, usually you are going to use number 2. Also guys, your finishing tool, it should be also, you need also to tell your machine what kind of tool are you using, what angle, cutting angle, nose angle. So since that one is turning tool, they are almost similar, they are just different in nose angle. Okay guys, so let's see this one later on once we run this one in simulation. Okay guys, let's find out if our program is going to work. First, we run this one in single block. So now the machine is going to do the pacing. 0.1 away from your set 0. And then we'll read the cycle for turning, the wrapping. Second pass. So guys, that's how you program your turning on this Doosan sensor lathe machine. This one is a Panok series. So this is now guys our finish phase. And then finish turning. Okay guys, thank you again guys for watching this tutorial video. I hope you enjoy watching it. And also guys, if you are happy on this tutorial, please give us a thumbs up, and also please consider subscribing to our channel, and please leave a comment down below that you subscribe, and I will try my best to reply to you as soon as I can. And see you on my next vlog. See you guys.